So in Basics A, number 9, it's about halfway into the packet. There was this question here, and there were some questions on this percent %s and what it does. So if you do system.out.printf, stands for print format. Uh, S stands for string, right? And there's also other formatting symbols like D for decimal and F for floating point numbers. Floating point numbers are doubles and floats. Well, what this does is it prints out this string in this format with the first percent %s being the next argument and the next percent %s being the next argument and the next percent %s being the last argument. So if you ran this through a compiler, what would it do? It would print out the star, a new line, the 3 stars, a new line, then the 5 stars, and a new line. So the only one that matches that would be this one here. This one doesn't match because it has 4 at the end. So that's how printf and the percent %s works. But to take it a little bit further, we would want to take a look at this problem here. And so what is this problem? This problem is a double x set to 0.1 and then a double sum equal to 0 we're using as a counter. And so what I'm trying to exemplify here is the problem with floating point numbers. So doubles are, I believe they're 64 bits, represented by 64 bits in the computer. So that's like 2 to the 64 is the biggest number that can be put together using a double. Like right off the bat, when you see double, normally you think of a number with 2 decimal places. That is not true, right? A double can have quite a few decimal places, as we'll see. And then we have floats as another data type. So if I had a float y is equal to 9, then this one's represented by 32 bits, right? Which is, quite a big number, but not quite as big as a double. So let's take a look at the double. What are we doing here in the for loop? We are, iterating 10 times, and we're adding it to sum. So the end result of this should be the number 1, right? And then we're double checking it, and we're just multiplying by 10 here. So let me just go ahead and take that away. And so we expect the answer to be 1, right? But what actually happens is this, right? So why? Well, the answer is kind of complex, and I actually don't have my head wrapped around it exactly, but we call it a round-off error. When you put numbers in as a double or a float, they can't be represented exactly. So there's a slight error. It's like a 0.000001 error. And then when you do arithmetic with it, that error is more obvious, especially when you do division. So so you have to take that into account, right? Whenever the test is telling you, oh, it's a float or it's a double, and then there's some arithmetic going on, then it is most likely there will be a round-off error down to the 0.00001. So if we had a question that looked something like this, like if x is equal to y, right? Then print hello. And then we said that double y is equal to 1. Well, what would this print? This would print nothing, right? Why? Because we did arithmetic. Oh, I'm sorry. This here should be sum. Because we did arithmetic using a double, and the number is not exact. So 0.99999 is not equal to 1. So then it would print nothing. It would print the else statement. So you need to take that into account. There were a couple of questions that I saw in Basics A and B, maybe one, that dealt with this. And then, so then that's something to keep in mind. And then another thing to keep in mind is that we can do this, right? And so what does this do? This percent %s prints out the floating number. And then if you put a decimal place number in here, then it will print to this many decimal points. So if I just do percent f here on these two floats, product and sum. Yeah, actually, so product is kind of the test case, right? We take zero point 0.1 and then we multiply by 10. You'll see that in this case, it will equal to 1. For that fraction of a time, it equals to 1 when you're dealing with floating numbers. So I go ahead and compile this guy. I run it, and here we go, right? We got 0.1, 0.1. Why? Didn't we already show that sum is not 0.1? I mean, I'm not 1.0. It's not, right? Well, when you do %s, it gets you automatically to 1, 2, 3, 4, 5, 6 decimal places, right? And %f rounds up, right? Rounds off. So, so that's something to note. And then if I put 0.2 here, and then 0.2, this number here represents how many decimal places to print out, right? So then when I go ahead and compile that, I run it, then I get this, right? 2 decimal places. And then if you notice, if I do 0.20 and 0.20, and then I go ahead and run, then I get my 0.99999 on the second one, on sum, right? So the lesson of this story is that when you're doing arithmetic using doubles, most likely 9 out of 10 times it will give you a round off error, right? So whether you're doing addition, subtraction, multiplication, or division, take that into account. Remember that. And then we have %f, which can represent doubles or floats, right? They're just floating point numbers. They're both categorized in the same box. And we have %s, which will print out strings. And then we have %d, which doesn't stand for double, it stands for decimal, which are used for integers, right? Where you could print out integers using printf. So there you go.